I'm Achin, and today I'll be talking on untangling the security of the SAML protocol. And in this talk, I'll talk about what SAML is at the grassroots, and we'll also talk about some attacks on it. We'll also discuss some countermeasures to prevent those attacks. And I sincerely believe that once this talk is over, whenever you guys see anything which says SAML while you're pen testing mobile applications or any kind of applications, you guys can comfortably say that, dude, there might be some problem with my SAML implementation. Okay? So, security interests me in its broadest incarnation. I've been working on HTML5 and protocol analysis for some time, and recently I got hooked into iOS security. Randy Pausch inspires me since the day I saw his last lecture talk, and it's worth seeing. I suggest you guys see it too. And in my free time, I play with my friends at a few pubs in Bangalore. So if you guys want free drinks, please get in touch with me. I took a long time to find this photo, and she's just a sexy end user. And like her and any other employee, they are not just limited to internal applications which are available in the enterprise. Can you switch off these lights? And as more and more mission-critical applications are moving beyond the firewall, such as cloud applications, software as a service, and other web services continue to rise, most of these organizations are finding a hard way to control their access and enforcement mechanisms, especially in the contemporary web. So, since there are so many plethora of applications coming in, one major problem prevails, and that is multiple usernames and passwords, right? I'm sure many of you must be using the same password for most of the applications you use on the internet. Gmail, Facebook, the same password is going everywhere, right? And if you're an enterprise, you have the domain credentials and you can access almost any resource that you want. But even then, every 3 months, the IT guy sends you an email to change your password, right? So password resets are something which are taking huge amount of IT resources, and it gets very difficult to manage so many user identities. And that's how the IT admins look like these days. Okay? So to combat this application sprawl and to manage user identities, what companies thought of were the single sign-on systems. And so over the years, many companies have marketed products which claim of selling web-based single sign-on products. And all these single sign-on products, they maintain the user's authentication state using browser cookies. But since everyone knows that browser cookies can't go between one security domain to another security domain or one origin to another origin, they came up with proprietary mechanisms so that they can transfer this user's authentication state to another security domain. So if you're in a single enterprise, if there is just one vendor who is giving all this to you, then it's perfectly fine, because it's just one proprietary protocol. You can use it in the enterprise and be happy about it. But if we are talking about a heterogeneous environment where we are talking to Google Apps, where we are talking to Salesforce.com, where we are talking to Amazon Web Services, it gets very difficult, because every service will need to have its own proprietary protocols to work, right? And things get really messy. So what happened? Some intelligent people, they sat together and they created a vendor-independent grammar protocol for transferring this information. And that was known as SAML. Now, SAML caught on very quickly with all cloud providers, Google Apps, WebEx, and all these things. And as soon as the traditional companies like IBM and Microsoft threw in their support behind SAML, it became the go-to SSO protocol. And the best thing about SAML is it abstracts authentication completely from all the applications. That's why it's rocking these days. And I've heard many people say that SAML is very difficult to understand, it's complex and scary. Maybe it is, because it's so big, it has so many entities inside it. But if you look at it from our perspective, from a security perspective, there can be multiple implementation flaws. And if the aim of this talk is to give you an understanding of SAML, so whenever you are no longer afraid of SAML, and if you are reviewing a SAML implementation, you can exactly triage where the issues can lie and where you have to look into.
What is the full form of SAML?
Security Assertion Markup Language. So before we go inside SAML, let's talk about a very general concept, the concept of federation. Okay? So federation is a concept which says how user identity would be propagated from one security domain to another security domain. For example, whenever organizations wish to make a collaborative environment where multiple services are there, different Google apps and all these apps which an end user can access, their employee can access, there are multiple systems involved. And not only they have to take care of the protocol, semantics and syntax, they also need to take care that they need to find out a shared identifier to which they can refer the user to about whom the information is being exchanged. So a user is said to have a federated identity if both the providers, Salesforce and my company, have established a trust and they agree upon a shared identifier. That may be Lady Gaga. So my employee is SpongeBob, but they can have a federated identity Lady Gaga. So whenever this guy is making anything sending any details to Google Apps or Office apps, it says that SpongeBob is actually Lady Gaga, and that's what this guy understands. And how this helps is because in all these services,
Slightly confused. What is the objective of this session?
The objective is to understand SAML and to understand various attacks on SAML and how to pen test SAML implementations. Okay.
So you mentioned about the federated identity. So are you trying to say that the principle that is being defined here is actually common across all the participating authentication providers?
Every user would have its own local identity in every security domain. So in your company, you are known by a name. In Google Apps, you will have your another username password. So we are unifying that. We are authenticating at just your company. And we are, at the same time, without sending your username password, without having multiple identities, you are authenticated. You are allowed to use all the services which are there in the cloud.
No, but you mentioned about a common federated identity. So
yes.
What I'm trying to understand is that remains constant across
between two service providers. It can be transient as well. Say, the user asks for a resource. I'll come to that. That's the next diagram. Would help you understand better. So let's talk about the most common use case of web-based single sign-on. And mostly what happens, I want to access a resource. Say I want to access something which is on my Google app. Okay, I'm an end user. I just have a browser with me, and I work for a company, but I want to access something which I have put on Google Apps. So what I do, I log into my browser, I type in the URL of the resource which I want to get, and I ask the service provider, which is Google Apps or Salesforce.com, to give me that resource. Now, the Salesforce.com says, okay, dude, you are not authenticated, I want to authenticate you. Then the service provider sends an authentication request. Now these are the terms which are very specific to SAML. I'll explain them later on, just bear with me, and just try to get a bigger picture of what I'm trying to say so that things are more clear and we can actually understand how SAML behaves. It sends the authentication request to the browser redirects it to the identity provider. Now identity provider is my company. It has its own Active Directory release. This assertion actually came. Sends it to the browser redirects it. The server provider validates the signature. It came from an authorized identity provider. I know this identity provider. It's not some random guy. And it authorizes the user. So the assertion also contains what kind of authorization this particular user has and redirects the user to the resource which he wanted to get. Now, SAML has a lot of components, and it is all these components which allow it to support a particular use case. And all these components, they are pertaining to sending authorization, authentication, and attribute information to different entities. So let's look at them in one by one. So the crux of the SAML protocol is the assertion, which one entity sends to another entity. In the last case, the IDP sent IDP means identity provider, the one which is authenticating. Service provider is the one which is providing the services. So the identity provider sent an assertion to the service provider, I have authenticated this user, please give him access to this resource. Now, in SAML allows one entity to provide security information about a subject in form of statements, and that's what is known as assertion. Everyone knows Shaktiman over here, right? Everyone knows Shaktiman. So let's take him as the subject. I think you guys will be able to relate it in a much better way. So there can be three types of assertions, okay? Assertion statements. One can be the authentication assertion, which I just sent from IDP to the service provider. Now, who authenticates Shaktiman? God authenticates Shaktiman, okay? So God has authenticated Shaktiman. And what are the attributes of Shaktiman? Powerful. And attributes as in what he wears. He wears glittery clothes. He wears golden clothes. And authorization decision means that what he is capable of doing. He is capable of flirting with Geeta Vishwas. Okay, he is capable of infinite power. Alright, so that's how assertions work. So I hope assertions can tell every information about the user which the server provider needs to know to give him access to the resource. And SAML is a trust-based protocol, so the service provider trusts everything which is coming from the identity provider. Okay, and that's how he gives him access. This is an example of a sample assertion. So we have our namespaces, XML namespaces. We have the subject ID which says Shaktiman who issued this particular assertion. There are some conditions which say that till which time window this particular assertion is valid. So this assertion is valid for like just 5 minutes. And as I said, there is one authentication assertion which I sent from IDP to the service provider. So I'm sending an authentication statement which was issued at this particular time, and who authorized it? The God authorized it. That. Okay. Protocols. Now, like any other protocol, you have a question?
Yeah, I couldn't really figure out.
Okay.
You were saying that the identity provider is also providing the authorization. So that means it is providing the granularity of access to different services, right?
It understands that the role of this particular user is just a user, it's not an admin.
Sorry?
When the IDP is going to authenticate that user,
Yes.
so he's just a user. He will specify that role. When you are giving that resource, so there would be proper, the service provider understands that. If a assertion has been sent from this IDP, if the role is user, I can give him this particular resource. I can't give him the admin resources. That way.
So the role is defined in the IDP.
Sorry?
The role is defined in the
Yes.
IDP.
That's where you are logging. That's where you are authenticating. Okay.
Where does the SAML come into the picture? I mean, for example, if you take a web application, where exactly is this fit in?
Right now, if you want to access Google Apps, you have your own username password.
Yeah.
If you are accessing Amazon Web Services, you have an account in Amazon Web Services, you have your own username password. Now what we are trying to achieve, since you are working in a company, if say company ABC has a trust relationship with Google Apps, you only have to log in at company ABC. Just one place, and you will be able to access Google Apps, Amazon Web Services, every single cloud-based service provider with just one credentials. So we are putting authentication at one place, and you can put your complete force in protecting that one place, which is your identity provider. And everyone can actually trust whatever identity provider is sending you, and the assertions the identity provider is sending you, and they can authenticate him and provide him the resource. You don't have to sign in at multiple places. So,
see, as I understand earlier, they used JNDI, some kind of technology where to do these things. I mean, this is a cluster of it, or how does it come into it?
I mean, the concept of why don't we take this online? We are talking more about the functionality part of SAML. So SAML is big. Of course, it's not that simple. It's a bit complex. But yeah, the use case is web-based single sign-on. So you log in at one place, and then you are able to authenticate to multiple service providers. You can just take it that way. Bindings. Bindings mean how SAML protocols are carried. So they may be carried using HTTP post parameters, HTTP redirect parameters, or SOAP protocol. So these are assertions. So assertion is part of the SAML protocol. So every protocol has its own request response structure. Right? So similar to that, how SAML messages are going to be carried, that's governed by bindings. So all these, what I'm telling you, are components. There are different specifications inside the huge SAML framework and the SAML protocol. And this is what all these protocols, bindings and assertions, they combine together to allow a specific use case to happen. That is, one of the use cases web-based single sign-on, which I just showed you. And there is web services. So you can also secure your web services using SAML assertions. So right now, web services, when you have to authenticate a user, you add the security header in the SOAP protocol, and then you give your username password. So any day, it's better to use a SAML assertion than just doing a database lookup and taking the username password and sending it across on the wire, right? It's obviously better to use a SAML assertion.
So can we use this alternative to web service if I have a...
No, you are not using it as an alternative. You are retrofitting the web service with security which SAML provides. Web service is completely different.
Okay.
Right now, how you authenticate a user when you are accessing a web service, you can use a certificate, you can use a username password. Similarly, you can use a SAML token. So that was something which I wanted to tell you guys about SAML, and let's talk something real fun. So SAML SSO equals to perfect security. So many organizations falsely believe that if they are using SAML to secure their online services, it's perfectly fine. It is obvious. It's true that it's more secure than using a username password, but using SAML does not solve the entire security puzzle. There are a lot of components in SAML which need to be in place if you want to prevent it from being attacked by attackers. And let's see what it doesn't do. Now, as I said, the identity provider only sends, the identity provider is sending a resolution to the service provider. So SAML protocol doesn't give any recommendation on how the IDP actually authenticates the user. He opens a form, he asks him to enter the username password, and the IDP makes statement, okay, I authenticated this guy. But how it authenticated? It said using password mechanism. It may happen that an identity provider may have a SQL injection. Then the whole SSO environment is any day broken. We are not talking about SAML over here. SAML doesn't say anything about the authentication mechanism. So whenever you are pen testing something related to SAML, don't just assume that it's a complete identity management solution and if I'm secure at all the points, the main place where the user is being authenticated, SAML doesn't say anything about that. Test it out and make sure that it's perfect and our SAML implementation is secure. Now, all these SAML conversations, this protocol, it is based on an underlying trust model. That is in turn based on the public key infrastructure. So there would be many keys involved, say signing and encryption. So there would be keys involved and we need to verify that the trust model and revoked keys and all those things have to be checked. So it's not like just assume that we are using SAML and the keys are in place, their revocation and all these things have been taking place. So since these things are big and they have a huge impact, even if we mess up one thing, the entire SSO security breaks. And again, there would be many places we would require to generate pseudo-random numbers and key storage. So all these things which we sometimes overlook when we are pen testing or attacking some big solutions, these have to be taken care of. So I'm going to explain something really trivial, but I just wanted this slide so that I can connect the dots and tell you guys how these three fingers of a protocol actually fit into SAML. So the index finger, authentication. How can you authenticate SAML messages? Any guesses? It's an XML based protocol. Yes. How can you authenticate the message level authentication? How can you do it? Say transport level authentication. How would you transport layer level authentication for SAML messages? What would you use? Yes, SSL would do. What about message level authentication?
XML signature.
XML signature, absolutely. What about confidentiality? Transport level, SSL? And message level? XML encryption. Integrity?
Signatures.
Yes, of course. So now since we know that we have the basic understanding of what has to be put in to give some level of security to SAML, let's talk about the real attacks. And in order to protect the integrity and authentication of a SAML message, as you said, we use the XML signature. But this XML signature is much more complicated than say OpenPGP or OpenCSL. Because those traditional signature methods, we just take the hash of the entire document, append it to the end of the document, sign it with a private key and send it. But in XML, the position of the signed content in the signature is variable. Right? Everyone understands that? Right? And that is why multiple permutations of the same XML document may exist. So, yes, we canonicalize. Canonicalization is different. But if the position is different, canonicalization is something like you have ID equals to double quotes ABC. If there is extra space in between, the whole signature would change. So we canonicalize it so that even if you're missing in these small things, we actually get the same output. So this is how the SAML assertion looks like with the signature. We place the signature over here and everything else remains the same. And if you talk about SAML processing, how SAML processing happens on the service provider side, it happens in two steps. One is the signature validation and the second step is claim processing. What is the role of the user? What are the attributes of the user? So what I just mentioned was just the role. There might be many other things which the IDP wants to send to the service provider. Okay? So that is the claim processing. Now these two modules, the signature validation and the claims processing, may have different views on the same data which is received in form of the assertion. Right? So the signature part of it is only looking at the signature. And most of the cases, if the signature is valid, it just returns yes. If the signature is not valid, it just returns no. And it's a Boolean value which is returned and the subsequent processing happens on that basis. Alright? So if I am able to make the processor, the XML processor, think that the signature is valid, but actually what was processed is something which I entered into the document, which I forced into the document, then things may go wrong. And let's look into that. Let's look into the XML signature, how it looks like and what are the basic concepts of the XML signature. So when people were making the XML signature specification, they were thinking of flexibility. And as you know, when flexibility comes into picture, security goes to the back burner, right? And there are two elements which are absolutely critical to XML signature. One is the sign info and another the signature value. So it's not like other signature generation methods where the signature value is of the XML content which we are trying to protect. So there is a message element which we are trying to protect. The signature value is not the signature of that XML content. It's the signature of the sign info element. And the sign info element in turn contains the digest value of the XML content that we are trying to protect. So the canonicalization method, when you are on the processing part of service provider, you canonicalize the sign info element. You use the reference URI. Now reference URI is again very important part of XML signature. So reference URI can be URI based or ID based. So say ID equals to foobar. So there would be a foobar element of which the digest has been generated. Okay. So on the server processing side, what happens? Is when you get this XML signature, you take the reference URI, you have the ID, you go to that element, you generate the digest value using the digest method, and then you compare this digest value with that actual thing. If it comes out to be the same, the validation proceeds. Okay, everything is fine. Then you calculate the signature value on the basis of the sign info, and that's how the processing happens.
How does the validation happen inside? Is it bound to some kind of classes or how is it?
Which validation?
You said some validation proceeds, right?
The reference validation. Let me come to that. The next diagram would make it clear. So this is how
your mic is on the floor.
Yeah. So this is how the XML signature looks like. You have the sign info element, canonicalization algorithm, signature method. There is a reference URI. So there is a who element which I'll compare the digest value of. Digest value, signature element. And XML signature is tricky, and let's see why. So, as I said, giving your answer, so when we are doing the reference URI, we have the URI value over here, which is a hash foobar, and this is ID based. So what happens is, it just goes to the actual element, which has the same ID. It generates the digest value of that and compares it with the digest value which would be there in the signed info element. If it's the same, the validation proceeds.
Does it have some parser running behind which does those validations?
Yeah, the XML libraries do that. libxml and all those libraries. XML processing libraries. Okay? Now, the problem in SAML is when there, as I said, there are two steps, signature validation and the claim processing. So the signature validation is ID based, but the claim processing is XPath based. So what if I do something like this? I take a signed assertion, okay? I take the message which was earlier there, I put it in another element as a wrapper element. The signature would verify this, it would come out to be true. But when I am processing the claims, it would come out to be like this. This is an attacker generated message which we have embedded in. Signature verifies, when I am processing the claim, it comes like this. And this type of attacks are known as signature wrapping attacks. So there is a very good paper by Gerard Szymborski, who presented a paper on breaking SAML, which mentioned some details about signature wrapping attacks. So I would like you guys to read about it to understand SAML a bit more. So how it actually happens. So I have the entire signature response element, and my assertion is somewhere over here inside the XML, the response element. And the signature is being calculated on the entire response message, the entire XML document. And what the attacker does, so right now he has a signed assertion. He has a signed assertion which says Shaktiman, he is a superhero. Okay? And then what he does, he takes the signed assertion, he puts his own assertion at the same place, response element as the child of the response element, and he takes this entire thing, puts it as the child element of the signature. Now, as the reference validation is ID based, it says, okay, signature is valid, perfectly fine, but when it's trying to process the claims, it says Kilvish Balu. Now, how it can impact the user? Say, I'm a user in a normal single sign-on environment. I log into the identity provider, get my own signed assertion, I'm a normal user. I can do the same thing and change this to admin. I can change my role to admin. I'll get those resources.
Doesn't it break the schema as well in that case?
So we'll come to that. That's another problem. On the server side, they always need to validate whether this is according to the SAML assertion schema. So most of the developers, they assume that whatever they are getting, it's going to have the same number of assertions, same number of signatures, and it's going to be according to the XML schema. The references would be properly linked, but they don't actually validate it. They don't validate.
The parser itself will be validating.
Until unless you give it the right schema, how would it validate it against? It needs to have something to validate against it. And every XML document would have a schema. So it changes it to kill vision and game over. So who can do this? As we discussed that the transpose level security is already predicted by SSL in most cases, and we are talking about message level stuff. And any soul who gets a signed assertion can do it. XSN in your site, you will get it. Register to the identity provider, get a signed assertion, modify it, send it as an admin. You are an admin. Googling. Can anyone tell me why I wrote Googling over here? You can just Google something. So basically, since I am adding my own assertion inside, the attacker is adding its own assertion, it doesn't matter whether the SAML assertion is valid or not valid. Right? It can put its own time and stuff, only the signature has to be verified over there. And the claim processing won't happen unless the signature is verified. And many times it happens that people put their signed assertions in forums, in different forums. They'll put their web services signed assertions on forums which are expired, so they think that things may not go wrong, or your own enterprise signed assertion, just to ask questions whether this is right, this is wrong, those kind of things. So you'll always figure out some of the other signed assertions from Google. Now, as I said, so developers make mistakes, and most of the time it happens. If we talk about Java, the programming interface is so complex, especially if namespace resolution and key store management comes into picture when you are processing XML signatures. Developers often resort to tutorials and online forums such as Stack Overflow, and that leads to replication of vulnerable design. Because the first place why it was written in Stack Overflow, it was not meant for security, it was meant for readability and understandability. People just pick up code from there, they copy paste and then use the same thing. One of the example is this. So I take all the elements by tag name, let's say SAML assertion. It would give me a list of all elements which has the SAML assertion, and this I take the first one, and this leads to the signature wrapping attack. Alright, so I'm not validating which signature is there with which assertion. If I'm only validating the one which has watch signed, those kinds of things aren't being communicated. Another thing is what the signature, XML signature verification module. So most of the developers who code this XML signature part of it, they are also familiar with the SSL verifying modules, because the same logic is being applied when you are verifying the signature. And by default, most of the libraries which are there to verify SSL based signature methods, they already do those trust-based verification, how the trust anchor looks like, whether the chain is valid, whether the certificate's been revoked. But when you come to XML, those libraries, most of them don't do it. So you have to take care that the keys that you are using, they are trusted before you trust them, right? They should be validated before we do some trusted operation which requires all these privilege levels. And as you said, there is a proper schema to every XML assertion or SAML assertion which we are going to use, every protocol message there, that is properly documented. We should verify every single assertion that we are getting according to the SAML schema. Don't trust keys, never trust keys. So in the signature part, there is a key info element which comes. And most of the time it happens that people also send their public certificates so that it becomes easy for them to verify, right? But the problem is, do not trust them. Because it's just coming from that party and you trust them without even validating whether they are true or not, it creates a problem. And there were many applications who actually do that. Everyone knows about XXC attacks, right? So XXC attacks happen because many of the XML parsers that allow custom external entities to be present to make the XML code more readable, and that is where these vulnerabilities arise. And many people feel that doc types are actually needed for SAML, but doc types are not at all needed for SAML processing. So these are one set of vulnerabilities which can screw your SAML implementation very badly. So make sure that doc types are not available. And when I was reviewing the simple SAML PHP code, they could have used PHP's own whatever library they were using. They could have used the default functions to disable doc types, but they used this method, which is absolutely fine. So simple SAML PHP, when I was evaluating, this is one of the best single sign-on frameworks which are protected against signature wrapper as well as XXC attacks, and it has been beautifully done. Shibboleth was vulnerable to XXC, but that was fixed. Then when I was reviewing some other SAML frameworks, I figured out XXC vulnerability in something which is in a vendor which is being used by a lot of companies. But the problem is those guys didn't fix it on time. So I could not make a disclosure right now. But yes, those kinds of vulnerabilities may exist in your SAML implementation, which is there in your enterprise, and most of the enterprises are moving towards SAML. So whenever you are reviewing this, please make sure that it's secure against signature wrapping, XXC. And XXC countermeasures are pretty simple. So all these XML parsers such as libxml and PHP and Xerxes 2, they come up with features so that you can disable them. This particular function can be used in PHP. And fuzzing SAML. So like fuzzing any other protocol, since I said that SAML is basically an XML based protocol, so all XML based fuzzing techniques would apply over here. The canonicalization, entity expansion. So someone who doesn't understand what C14N is, that's an ID given to the canonicalization processing which happens in XML. XXC, you can check for XXC attacks, signature wrapping and exclusion. In some of the products it was found that they don't care if the signature is not even there, don't even validate it. And if it's there, they do validation properly, but it's not there, okay, go ahead, let's do the claim processing. So there is a WAttacker pentest library which has some web service attacker pentest library which has a lot of attacks about how to attack XML based protocols. And fuzzing of attributes is again there because there are a huge number of attributes in SAML, and you can just make a library and fuzz them. And again, check for SAML schema confirmation. If that is perfect, I think it will break your SAML implementation. Few more things. So once assertions are out of hand of the IDP, so IDP sends the authentication assertion to the service provider. It's up to the service provider to decide whether it wants to keep the assertion with it. So the IDP doesn't know for how long the assertion will be kept inside the service provider, or the service provider may transfer the assertion to another service provider, and SAML provides that as functionality. But if in your implementation you don't want it to be used again and again, there is an attribute which is provided for security, which is the one-time use token, which you can use in the SAML protocol, and make sure that every assertion has this in the conditions element, so that this assertion is used only once and it's not used again and again. Handling SAML is expensive because when you are processing the response, it requires a whole XML DOM to be created, and at the same time it would require database lookup and one or more signature verification steps, and that is why we can use some mechanisms to prevent any kind of denial service attacks, which is always prevalent in XML based protocols. So one is using the client authentication, use client certificates. Although this doesn't protect against denial of service, but it at least acts as a deterrent. It would help in traceability from where the DOS attack is coming. All those things can be protected against client based authentication. And requires signed requests. So just out of a feeling that signed requests would make my SAML implementation more complex and do a lot of processing things, I think don't worry about them. They help you make your protocol more secure. Use them judiciously. Replay. So although the transport level protocols that we will use will protect the SAML request and response messages against replay, but if we talk about message level, what are the message level, what are the SAML protocol level we can do? We can always check the issue instant element which is there, which was there in the assertion. We can always check that, whether the assertion was actually made a long time back or it was made recently. We can check that and deny if any assertion is expired. And every request would have its own ID. Every SAML request would have its own ID. We can check that. If there is a replay happening, we can check if this ID has already been received. Few more attributes, as I told about not before and not on after attributes. These attributes define the time window for which the SAML assertion is valid. It should be the shortest possible validity period. And another is the subject locality attribute, which can be used to put the IP address from where the assertion was sent. So you can check the browser IP address and this IP address and see if no one else is sending the assertion, and it's the same machine which you are actually communicating to is sending the assertion. So these things just raise the bar. They are not complete security mechanism, but these things would make your SAML implementation much more secure than what it actually is. Now, let's come to securing web services with SAML. Now, as I said, you must have heard about SAML token all these days. Mobile applications are SAML token and all these things. So whenever you are communicating to web services, there is a WS security standard which defines how web services can be made secure. And over there, as I said, you can send username, password to authenticate a user. You can send certificates to send a user. At the same time, you can send SAML tokens to support the user. So identity provider can use that token, different service provider, and the user can actually send those tokens along with the web services request, so I can get those resources.
How do you do that? Okay, how do you send a token to a SOAP request and response?
So inside the WS security standard, right, there is a security element which you are sending with every web service request.
Okay, and it goes to the consumer of the...
Yes, consumer. Yes.
Okay, after that, who verifies?
The consumer verifies it. Consumer verifies the token on its end.
But again, do you need to have a separate client to decode what exactly the SAML message is, or
yes,
is there any separate parser over there?
Yes, it's the same XML parser. It's like any other XML parsing, where you just need to have the right logic. And you have to make it according to the SAML specification so that you understand a protocol. It's like developing a protocol, client and server. Yep.
With SAML, right? Open SAML, and if I'm using Open SAML, will this token be encrypted or is it like this?
You can use XML encryption, of course.
Okay. So if I use XML as encryption, is it going to encrypt my entire assertion or just a token part?
XML encryption you can use to encrypt the entire assertion as well. I mean, it won't encrypt other parts of the XML content which are there. You can add, say, if you're talking about web services, you can use XML encryption to encrypt just the assertion, anything else.
Now it comes follow this. So when you decrypt the assertion and see what is there, right, that's easily decrypted by SAML or Firefox channel servers or something like that. So when you decrypt it, it clearly shows the destination or what server protocol I'm using, where the source is from. So these informations are available.
Yeah.
I think with these vital information, still I can launch an attack to the SP or service provider or consumer. Right?
But yeah, so then what we talked about, the signature or protecting the integrity of it. So if the user is logged in, if say I log in, only I'll be able to use the resource because the integrity, my role, my subject, my email ID would be there. And the service provider identifies me using that email ID. And it has its own federated identity too. Like if I receive SpongeBob on the service provider, it already knows that I am Lady Gaga. I'm not SpongeBob. Okay.
Oh, okay. So that's in the subject matter.
Yes, subject name ID. Yes, there can be multiple attributes. So if you don't want to point at a user just from the subject ID, there can be multiple attributes which you can use collectively to actually identify the user.
But you cannot encrypt the entire assertion.
See, XML encryption is something which which is not normally used in SAML protocol because it's already protected at the transport level by SSL. XML encryption is just an add-on which you can use, although it's already protected. So it's more or less more important to protect the integrity of the SAML assertion. Even if someone sees that information, they won't be able to do anything about it because it's protected by integrity. So they already have the federated identity. Service provider already maintains a federated identity. So you can't actually take the signed assertion, send it, and you can just log in. It's not possible. That's why that all these time values which I said, that not on before, not before instant, they have to be verified and they need to be validated.
Is this valid for all the versions of SAML or these attacks?
The SAML 1.1 standard is a bit old. Right now, from the past 5 years, the SAML 2.0 is the one which is popular. So these attacks are valid on SAML 2.0. So what did we learn today? Signature wrapping attacks is not a cute bunny. So whenever you are pen testing SAML implementations, make sure that you are protected against XSW attacks. XML parser attacks, all XML parser attacks, they apply to SAML implementations. And SAML specification provides few recommendations on hardening, which I just told you, a few attributes which you can use to protect your SAML implementation. And make security fun, attack your own SAML implementation because that's what we are good at, breaking things.